Hello there, folks. It is 2 o'clock, and this is Unhindered by Coding, live streaming, me writing programs. I'm Nick McPhee. I'll be coding the next 2 hours. Hello, esitsu again. Wonderful to see you, as always. And everybody else who's here. There seem to be quite a few lurkers. Feel free to say hi if you are so inclined. So this will be, for the next 2 hours, we'll be starting a new project. So this slot has been sort of dedicated to doing systems lab work. So we have a systems lab course here at University of Minnesota Morris. And it's a 2-credit course, meets twice a week. In the lab, and students work in teams on a variety of systems-related projects. That coding is initially in Bash, so as an opportunity to learn how to do some shell scripting, and then some C programming to learn the horrors of manual memory management, and then kind of the back third of the course is mostly in Java, which the students know coming in with varying degrees of confidence, but they do have experience with Java coming in. And so I've been looking at writing some of those, solving some of those lab problems in Rust as opposed to Java, to think about whether we should be considering, whether it would make sense to consider rewriting some of those labs so that the students actually do them in Java, either do them in Rust, either instead of doing them in Java or as well as doing them in Java. It could be either way, kind of depends. We finished over the past month building an Echo client server system in Rust, and that was pretty straightforward and fun, and learned to do well. Hello, PZ Myers. Thanks for joining. That was pretty straightforward. I think we spent a lot of time because I figured I'd learn about the error stack crate for error management, because there's a lot of error management in that. And I think that was probably overkill. I don't know that that would be something I would do again. But we also learned the clap command line argument parser crate, and that was cool. And I definitely would use that again. And there are other error handling libraries like anyhow and things like that. So there might be some other options that would be useful. But I'm not sure, at least in the Echo client server, whether any of that's really necessary. Don't know if that'll come up here in this next project or not. So the next project, actually, that I decided we'd work on is one of the more complicated, and actually, since we got some new people here, here's the invite link to the Discord server if you are so inclined. One of the more complicated labs in the course, certainly I think the most complicated or tied for most complicated, depending on your point of view, is the segmented file system lab. And that's what I think we'll actually implement over the next few weeks here in Rust, because I think that would be one that I think it's a good fit. The language is a good fit for the problem because you're doing things with essentially raw arrays of bytes. I think it's a tricky lab. And a lot of it's sort of data structures and types. And so I'd like to see how that plays out in Rust, what the type system looks like, and how the type system interacts with the problem. So we'll start that today, and we'll see how that goes. That's the plan. So let's get out of here and look at the problem for a second. So the problem is there is a server. There's a lot of text here. Let's actually try to skip most of this. I'm going to make this bigger and get us up to here because I think that'll be the simplest place to start. So there's a server running and it's using the UDP protocol. If you're not familiar, so there are two key options for this kind of network communication. There's UDP and TCP. TCP is much more widely used and provides a lot of guarantees that UDP doesn't. So UDP is lighter weight, tends to be used for things like streaming, where if you lose some packets, it's not likely to be a big deal. But TCP is by far more common. We used UDP here on purpose to make things complicated. So one of the guarantees that TCP gives you is that packets will be given to you in the order that they were sent. So if you send a bunch of packets from a server to a client, they may arrive in randomized order because they move out across the network. The routing algorithm might send them along different paths, and a later packet might end up passing an earlier packet because it got on a faster route, and that earlier packet got delayed somewhere in a switch for whatever traffic congestion, or it got mangled and had to be resent. So these packets arrive kind of in random order. The modern internet is actually really good at delivering things correctly and quickly. So in fact, you don't get a lot of, in real life, you don't get a lot of randomization in packet order, but it can happen. And TCP promises to fix that before you see them. So when you receive a bunch of packets from TCP, they've been sort of put back in the right order. And TCP ensures that missing packets get resent, and it will also reassemble. Like if a big thing is broken up into several packets and then sent, TCP will reconstruct them into the big thing before they hand it to you. So TCP does a lot of nice bookkeeping, and you can kind of, if you think of it as being used, for example, for file transfer, at the TCP level, you can be like, the server sent the file, I received the file, done. UDP doesn't promise any of that. So in UDP, the server will send a bunch of packets, and you'll just get a bunch of packets. You don't know what order they go in. That information has to be in the packet somewhere because otherwise you have no idea. You are not promised redelivery of lost packets. We are in this lab assuming that no packets get lost. We've actually, as a simplification, we've kind of assumed that no packets get lost, and on especially non-Wi-Fi networks, I've never actually seen a packet get lost. The networks are good enough that that's not been a problem. We have occasionally, but again, quite rarely, seen packet loss when people are using Wi-Fi on campus, but that's pretty rare. So it's generally not been a concern. So you receive, you contact the server, and you send them basically just a like, I exist. So the initial message you send the server doesn't have any content. And it's really a way of saying, here's my address, send me some stuff. And the server then is expected to send you a collection of files. And in principle, you don't know how many files. In practice, the server sends 3 files. It would be interesting to change the server so that it sends you a random collection of files and a random number of files. But for testing purposes, it's easier for everybody involved if like the set of files is known so that you can more readily tell if you've got the right thing. So the server sends 3 files. There's a little text file, a long text file, which, if I remember correctly, is the entire text of Shakespeare's play As You Like It, and an image file, a JPEG. So there's a file that's a binary file. And it sends these 3 files. And these files are broken up into packets that are, each contains at most a kilobyte of data. So As You Like It gets broken up into a few packets, not too many. The little file fits in one packet, so that's no problem. And the JPEG gets broken up into some number of packets. It's a pretty big JPEG, so it's several packets. I think in the hundreds of packets to send that. And so you get this blizzard of packets come at you over UDP in random order. And you have to then, for each packet, decide which file does this packet belong to. And when you've got them all, well, you have to decide if you've got them all. And when you do have them all, what order do they go in? And then when you have all that information, you write the data to a file. And hopefully at the end, you will have written the 3 files, and they'll be the same 3 files that you were sent, and life is then good. And so that's what this project is going to be about, is sort of receiving this blizzard of packets, doing the data structure management to figure out who goes where, and writing the files out to the file system. Some of the basic network communication will be pretty similar to the Echo client server we've been doing, but the data structures work on the back end is going to be completely different. And the packet structure is pretty random. Like, we just invented something, partly to make the problem interesting from a lab perspective, and certainly I would make no claims that this is like the one true way to, written this protocol, but it's a thing that works. And it's been a pretty good lab. We've used it for a number of years, and it's been a pretty reasonable lab. So what do we actually get? Because this is actually what I want to start with today, is sort of receiving and parsing packets. So turns out there's 2 kinds of packets. Let's actually back up a little bit. We'll look at some of the... so there's a header packet for each file being transferred, and then 1 or more data packets for each file. And the header packet is mostly there to give us the name of the file. It could also include other information, like how many packets belong to that file. And that would actually be a pretty rational thing to do. But we made the lab more complicated than that. And we don't actually explicitly tell you how many packets there are in a file. That you have to kind of infer that from some other information, which we'll talk about in a second. And a header packet has a unique file ID, and then data packets also have a unique file ID. The packet number, so the packets for a given file are numbered so we can order them properly later, and then the data for that data packet. So here's the structure. A header packet has a status byte, which is 1 byte long, the file ID, and the file name is in the rest of the bytes that are in the packet. So everything after the first 2 bytes should be interpretable as a string that can be thought of as the file name. And the status byte, actually I should have said something about the status byte. So every packet starts with a status byte, which indicates what kind of thing it is. So if the status byte is even, then it's a header packet. So essentially, if this byte is even, if the least significant bit is 0, then that's a header packet. If the status byte is odd, then it's a data packet. And for reasons which will become clearer in a second, if the status byte, so the status byte being odd means the least significant bit is 1. If its second least significant bit is also 1, so one way to think about it is it's 3 mod 4, then this is the last data packet for the file. So instead of saying up front, there are 12 packets with this file, which you could imagine putting in the header, we instead have a marker on the packet that is the last packet for that file. So you have to use that to figure out how many packets that file had. So when you receive this, if that packet number is, say, 13, then you know that there should be packets 0 to 13 for that file. And so if you don't have all 14 of those packets, you're not done. You're still waiting for more packets. And so the data packets have the status byte and the file ID, so that's the same. The packet number is then 2 bytes, and those 2 bytes have to be like interpreted as a number correctly. And one thing I don't know is that might turn out to be really easy in Rust, because we might just be able to parse a slice of the U8s as a U size. Don't really know. Have to figure that out. Or actually, I guess a U16 would be more appropriate, since we know it's 2 bytes. And then the data is in the remainder of the packet. And one of the things that's complicated is all the packets are randomized in order. In fact, the server is written because, like, especially small local networks don't tend to randomize packets very well, because everything is pretty reliable. The server literally just shuffles all the packets before it sends them out. So every time you call the server, you're going to get the packets in a totally random order. So you're going to need the header packet, but it might not be at the beginning. It might be the last thing you receive, or in the middle, or who knows where. And you're going to need the last packet to know how many data packets there are. But again, that could happen at any point in the process. Could be the last data packet you receive is the last packet, or the first, or the 7th. You have no idea. So you're going to get all this random stuff, and you're going to have to like store it, and then figure out, like, have I received everything? And when I've received everything, then everything's got to be like assembled into a some sort of data structure that can be written out to the file system as a new file. So that's the basic idea. That's a lot. Are there any questions about the setup? And if you want to read more, here, I'll put the link to the write-up in the chat. If you're really bored and want to read the details, that's the write-up for the lab. And the repo that I've created, which is here? No. Oh, I don't even have that open here. GitHub.com Rust segmented file client. Oop, dadgummit. Try again. GitHub.com Nick McPhee segmented Rust segmented. There we go. So this is the repo we'll be working on, and it has a pointer to the lab in it if you want to go read all the gory details. So that's what we're going to work on. I would expect several weeks before we're done, but I don't know. We'll see. Depends on how much faffing about we do and how lost I get in places. So I want to start today actually with trying to work out the packet structure itself so that we can receive and create packets. And it seems to me that we've got essentially an enum sort of on the target side. After parsing, we have an enum with 2 options, a header packet or a data packet, and then each enum will have an associated structure that will have these pieces. And if we wanted to get fancy, no, actually we don't really. I was going to say we could like try to do something fancy about sharing, but really we don't need to here because the status byte will disappear as part of the parsing because it tells us whether we're a header or a data packet, and so that'll get absorbed into the enum itself. Everybody's going to need to have the file ID, and then the header packet will have the file name, and the data packet will have the packet number and the data. And so I think those are the data structures that we probably want. And so I think that's a reasonable place to start. And then we'll have to use I'm going to use the Tokyo networking library to connect to the server, get packets of data, and then hopefully parse them into things. So that's the idea anyway. Okay, so let's see if we can make some of this work. I'm going to close that. Source. I'm going to make a lib directory here. And in that, I'm going to make a model. Actually, I'll call it packets.rs. And so our lib is going to have. Oh, no, that's not supposed to be a directory. I never remember the order of these things. If we look at actually, I want to look at the Echo client server. That would be particularly useful. Rust echo. And because that's got a file structure. So it's lib.rs. Oh, that is not so helpful. I obviously really wanted ice-repos because that actually has a full structure in it. Oh, go away. Oh no, I want you, not you. So lib, we'd have a module that would have stuff in it. Okay. So I really didn't want a lib directory here. I want packets to probably come out to here. Yes, and I want this to go away. Delete. Oh, go away. Here we go. And I want a lib.rs. Lib.rs. And if we so we just have pubmod packets, and that will then pull in packets.rs. Zippity doo dah. Okay, so packets, and now this is where we're going to want to start defining our packets. And like I said, I think we're going to want an enum, which we could just call packet, and it's going to have two variants: a header, which is going to need to have what do I want to call that? Like header packet, but that seems too many headers. I don't think I can say, well, can I just say header again? And then header be a struct? Data. that actually work? Struct header and struct data. That does appear to compile. Oh, that's interesting. Okay. Now, do I like that as a naming? I think I do. I don't know. I'm not sure how I feel about that. If you have thoughts, feel free to share. And then a header. So esitsu likes it. If esitsu likes it, almost certainly good. Nah, actually, if other people have thoughts, you should totally share. Then, so a header packet has a file ID and a name, which we presumably want to be a string or a stir slice, probably a string. So we're going to have a file ID, which is going to be a U8, because we only have one byte for the file ID. We know that fits in a U8. One thing that's actually going to be nice about Rust versus Java is Java doesn't support unsigned integer types. So you have different sizes of integer types, but they're all signed values. And there are some places in this lab, I think in the construction of the packet number, where in Java that's actually a real pain in the butt, because you really want to treat both of these bytes as unsigned values, and you have to do some futzing to make that work. And I must say, when I first started learning Rust, the sort of explicit number of bits, U8, U16, was like, oh, this feels very sort of low level and grubby in some ways. It's kind of nice just saying, like, this is an integer and I don't care. But actually, for something like this, where you do care exactly how many bytes things have, or bits things have, I think that'll actually turn out to be really nice here. We can be quite precise about our sizes. And then file name will be a string. And then the data has a file ID, a packet number, and data. File ID, U8 again, a packet number, which was a U16, and data, which is going to be, and this is a place where Rust is going to help. One of the mistakes that students will sometimes make in Java is they'll store basically a pointer to the data in a packet that they've received, and that's in some buffer, and then the next packet overwrites that buffer, and that pointer is now pointing to random data that's totally different than what it was before. And so you've got to copy the data out of the buffer into whatever your data structure is, and Java doesn't make you do that. Rust, I'm pretty sure, will make you do that. I think there's going to be, I presume there'll be an ownership issue if we try to, like, you could imagine making this something like that. But I think that you'd end up with an ownership problem, and there'd be all kinds of shouting. And that Rust is going to, like, force you to deal with that in a more reasonable way. So I think that we'll say this is a vec of U8. And that'll force us to copy the data into here out of the slice in the buffer. So good question. Is the data size fixed? No, but it is bounded. So we promise that there'll never be more than a kilobyte of data in a given packet, with that plus the 4 bytes of bookkeeping mean that a total packet size is never more than 1028 bytes, so that we can use a 1028 buffer and know that will be big enough to write the entire packet into. And with UDP, I think that's the best you can do. I think there has to be some kind of prior understanding between the two parties about the bounds on the packet size. But I am not a networking expert. I wrote this lab. I have never write code like this. This is way outside of my realm of general experience. I just felt like, we needed to have something in our lab set that got down to this level. I just don't ever do it myself. And, so I learned enough UDP, networking, stuff to build a lab that I thought was reasonable. But I am by no means an expert. Oh, I see what you're saying. I think the answer is no. And the reason the answer is no is for both, and this is another subtlety that I didn't mention earlier, but we definitely will have to run into. For both of these, we have an upper bound on how much data there is, but the packets aren't guaranteed to be full. In particular, the last packet usually isn't. Unless the file that we're moving happens to be an exact multiple of 1028 bytes, the last packet will only be partially full. So when we receive the last data packet, for example, there might only be 17 bytes in it. And so we could have a fixed length array here, but then we need to add another field, which is how much of that array is actually being used. Because there'd be potentially unused bytes at the end. So I kind of think a VAC is just as simple, because they'll mostly be 1024 because most of the packets are full, but they won't all be. And so this way we can take the slice of actual data, turn it into a VAC, and then store that, and it'll know how long it is, and we don't have to worry about it. That was the way I was thinking about it. So if you think there might be a better way, I'm definitely open to hearing that. We also have to be careful here that the file name is only, I think the long file name might be 15 characters long or something, and this could be 10. Oh, go away. This could be 1026 bytes, and we definitely don't have file names that are that long, and so that'll be one of the things that'll happen when we convert to a string here, is we'll need to get the right part of the slice, parse that as a string, and store it, and that'll be how we'll kind of ignore all the extra stuff at the end. So I think this is a reasonable approach, he says, hoping for the best. But if anybody's got alternatives, definitely let me know. Now, I think we could use we could implement a from trait that would take a slice of U8s and convert it into a header, and a slice of U8s and convert it into data. We could potentially have those return result types. Take a look at the zero copy trait. Rust 0 copy. Ho! Yes. This could be certainly very useful. So from bytes actually is exactly what we want. We don't care about as bytes because we're not, if we were writing the server, we care about as bytes, but we don't care about it here. And byte order might turn out to be important because we've got to make sure when we're converting in the wrong place again. When we're converting these 2 bytes from bytes to a number, we got to make sure we get the byte order right. Yeah. Cool. That should... okay. So, there's also bin code. Rust bin code. Yeah, I didn't actually do any searching to see if there were crates that would be particularly useful here. I just, it didn't occur to me that there might be stuff, but in retrospect, I guess that was, could well be. For encoding and decoding using tiny binary serialization stereo, you can easily go from having an object in memory, serialize it to bytes, and deserialize it back. So it's like we can take this string and serialize it and get a vec of U8 and vice versa. So that could be a useful thing as well if we need that. I'm not sure what the best options there are. The only thing that requires any real interesting, well, there are 2 things that require parsing of some consequence. We've got to convert from a U8 to a string here, and we have to convert the 2, let's see, that's over here. Yeah, we got to convert these 2 bytes to a packet number. Everything else is really, this is just a number, so we can just treat it as a U8 and move on. Here we're just, we looking at specific bytes or just doing modular arithmetic. Is it even or odd? Multiple of 3 or 3 mod 4. So here we don't have to do any interesting parsing. Here we do have to convert to a string. Here we just keep treating this as a bunch of U8s and ignoring their values. We don't do any interpretation here. And we do have to then do some parsing here. So there are a couple of places we have to do a little parsing. And the 0 copy might be useful for getting the 2 bytes to a packet number. I think about that. But I think the string, I think we can just, there's something that'll just parse a string from an array of U8s. I don't think we have to do anything fancy there, I think. We'll see. So let's actually see if we can maybe write and I guess we're going to need some sort of function and it could be an associated function with packet that tells us impl packet fn is header. Oh, and that would take a slice, so bytes, slice of U8, and return a Boolean. And that would just be headers are true. It's a header if the first byte is even, right? Header, yeah, if the first byte is even. So we could say bytes 0 mod 2 equals 0. Oops, return. It's not mod, it's probably percent. And that's happy. Now, this does assume that there is a byte 0. And the type here does not guarantee that there's a byte 0. So we could ignore that and have a runtime error. I mean, it shouldn't ever come up. The server never sends malformed packets. So we should be okay. But again, one of the things I like about Rust is the runtime safety that we can get. And so it is dimly possible, well, not dimly possible, it's entirely possible, even if our server never generates them, that we could for some reason have an empty array here. So we could either assert that, and it's interesting that this doesn't, because we're just dealing with arrays, it has no idea how long this is. Well, it does, but it doesn't know it until runtime, so it can't tell if this is a worrisome thing or not. So we can either assert that bytes has a length greater than 0, or we could return a result type with a malformed packet error or something like that, and deal with that if it were to come up. I kind of actually like that latter option, maybe. It might overcomplicate things under the circumstances, but I think that we could do that, and we need an error type, which is going to be packet parse error, and that means we'll have to define that. Let's put that up here, and that's going to be enum packet parse error, and we're going to have some options. So a malformed packet, for example, will exist as an option, and then we would say if bytes.len equals 0, return error packet parse error malformed packet, and otherwise we'll return that in a okay. Boom, ba, ba. Okay, so that's a thing, and that return. So we'll check to see if it's doesn't have enough bytes. If it doesn't, then we'll return a malformed packet. we could return, maybe we call that empty packet actually. Empty packet. I like that better. Yeah. Or actually maybe no header byte, because maybe what we want is errors that are like, we're missing this, we're missing this, we're missing other pieces. And so that would maybe be more consistent. So maybe this would be no header byte. Rename no header byte, which is the same in this case as empty, but it'd be a little more consistent, because then we could have like no packet number and things like that when we get there. So there we have packet is header, and we should probably write some tests. So CFG test, I think, mod, I didn't remember, haven't done enough of this, Rust testing. Let's have a look at an example so that we mod test, so we have a module and then we have stuff. Okay. Now if I have testing for individual structures, I don't know if I can open and close the same module multiple times, or if I'll just have to have different modules, but we'll figure that out as we move along. Is header, so we can have a test called is header. We'll make a let bytes equal vec bang, and then we provide a set of bytes. Oh, we're probably going to have to say that this is U8, aren't we? Vec U8. And we want the first one to be even. So I think in the server it's actually 0, 1, and 3 are the only numbers that are actually used, but we can check a couple of different values. And then, I don't know, 5, 8, 9, 6, 3, 2, 0. So there's some bytes, and we should assert that that is a header. So let result equals packet is header bytes, and we want to assert that result is okay true, I think. Run the test. Whoa, didn't like something. Packet, oh yeah, so I didn't import use superstar. So that'll import everything in the surrounding module. So packets is implicitly a module, so every file gets to be its own module whose name is inferred from the file, and then a module inside of that is a sub module of the surrounding module. So tests here is a sub module of packets, which is part of how we can have tests in lots of modules. They don't run into each other, but we do have to, a sub module can't see its parent stuff. The parent can see the child stuff, but not the other way around. So we have to bring that in or that won't work. And we didn't like that. What is going on here? Mismatch types. Expected a U8 but found a vec. Oh yes, and it's even yelling at me. So I should know that there's issues here. So I need to, if I borrow, then I will get the bytes. So yeah, since we're getting a reference to an array of bytes, if I had put the bytes here as the vector, then it would have actually passed ownership of the vector to isHeader, and we wouldn't have had access to it later, which in this test is no problem, but would almost certainly be bad somewhere else. So what I really want to do is pass a reference to the array of bytes, which is implied, well, not implied, it's stated explicitly here that this would be a reference to an array of bytes. And so if I take a reference to that vector, it can pass through as an array of bytes. And so that part's now happy, but this is grumpy. Why are we grumpy here? Packet parse error doesn't implement debug. Well, apparently I've got to derive debug for the error, right? Packet parse error. Okie dokie. Derive debug. And do we have to derive some other things? Yeah, sure. Partial equality, because it's doing equality comparisons and it doesn't know how to do that if I don't tell it. So we also have to derive partial eq, and we can take the default implementations of both of those because they'll be fine for us. Run the test again, and now I think we've just passed. Woohoo! Our one test passed. Aren't we awesome? The little things that make us happy. Oh, stop that. My trackpad is getting sticky in its old age. Oh, come on. Let go. Thank you. Cool. So that's good. And a whole bunch of warnings, but that's no big deal because it's a bunch of we haven't used things. And so we'll write some tests that'll make that usable. So that works. We could make another test with a different even number at the front. I don't know, 12. And that ought to do the same thing. And fun is not header with 1. And we'll have fun is not header with 3, because I think that's the other one that the server actually uses. Oh, and got to remember to put the little test annotation in front of these, or they'll be like, I don't know what this is doing here and it's never being used. So this is, and I say I wanted to pay, oh, fine. Pop this in here and make this 1 and 3. And actually I'm going to run this, and that should hopefully fail those two, and it does. If I run everything, then we get 2 passed and 2 failed, and the 2 that fail are the 1 and 3. And I guess actually it wouldn't be a bad thing to change both of those and confirm that they fail. All 4 of them fail. Yeah, good. It's always good to make sure that you can fail a test. And so this would be packet parse error, no header byte. Nope, not. No, it doesn't return an error. It returns an OK false. And this returns an OK false. So now I think those tests will all pass. Yeah. And then I guess we ought to actually confirm that we get our error. Test fun error on empty array let bytes vac u8 equals vac bang 0 or empty, sorry, and then let result equals packet is header ampersand bytes, and assert eat bang result, and that's going to be ERR packet parse error no header byte. Boom, bop. Run that one, and that passes. Now I feel like I've done this wrong. I mean, I think Rust is agnostic on this, but they, oh no, here they have the computed result and the target as the second. So, and that's what we've done, is computed result and target is second. So, okay, we're following the Rust book, I guess, on that regard. So we'll call that a win. And so that, I think, now why does this say it is never constructed when we used it right here? That confuses me. Unless it's because it only happens in an array, I mean in a test. Oh, and I guess is headers listed as never used. Yeah, so I think if they're only in the tests, because they wouldn't be included in production code, typically, they're counted as we're still not using it. Okay, that makes sense. I'm still a little surprised, I guess, because this is never used. By extension, things it uses are not used. But if we were to use this somewhere, then all of a sudden that warning about no header byte would go away. Okay, so let's run all the tests to make me happy, and all 5 tests pass, and life is good. Okay, so that's cool. And we can tell header packets from non-header packets. So we now can talk about parsing a header packet, which is presumably going to want to be an impl in header. So we're presumably going to want to have impl. Let's see, do we want to, I guess this is the question, is do we want like a from thing or one of these nifty deals? So from bytes, says that we ought to be able to read from a slice of bytes and make a thing. So we would implement from bytes. A length and alignment checked reference to a byte slice, which can be safely reinterpreted as another byte. What does that do? Oh, and actually this is UDP headers. Holy moly. So we're saying that we've got two U8s, two U8s, two U8s, two U8s, and layout verified. The UDP packet will have a header, which is a layout verified of a UDP header, and a body. Huh. And then we have a parse that takes bytes and returns an option UDP packet, and we do new unaligned from prefix bytes, and that gives us the header and the body. So that would actually split out the header part, these 8 bytes, from everything else, and parse the header part into a UDP packet, a UDP header, and then give us that structure back. That is very cool. That would be a really neat way to do this. Now, esitsu says this is not compatible with what we've written, but we can restructure it to be compatible with this. And I would like to come back to zero copy, because I feel like zero copy would be the kind of Rust way to do this. But I don't actually want to do it this way, because I want to think about how this would look. Like, I would never ask the students to do it this way. I think I would ask the students just to, like, I wouldn't want to, like, throw a bunch of complicated crates at them that are doing, like, fancy, nifty Rust magic. I think I would just be like, here's the packet structure, you kind of parse it. And so I think that's how I want to at least first do this. But I might make a note that a zero copy thing might be fun to look at later. Could use the zero copy crate to auto magic some of this conversion. So I'm going to impl header, and I could do probably a from thing, implement the from trait. But yeah, that was, I think to give that to students would be awkward. Yeah, the TryFrom, I think that's actually a better way to do that, because then it allows us to have errors like this. I think that probably makes more sense. So esitsu, or anyone else, but I know esitsu's got experience with this that I don't have. Do you have a sense of, like, should we be like dropping the tests just right in the middle of the file like this? Should they all be at the bottom of the file? Am I going to have enough tests that I really ought to put them in a different file altogether? I don't have a great sense of this. I seem to remember that I read somewhere that kind of unit tests, which is what these are, it's recommended that they be in the same file. But I'm a little anxious, if I have a block of tests like this, and then we get down to header, there's going to be a lot of scrolling around because you have to scroll past the tests a lot. And it seems to break lexical proximity in some ways. Okay, I'll go with the bottom because that was bugging me. So I am convinced because it didn't take much to convince me. Yeah. And let's see if I comment that out for a second. We should also compile, and the tests all pass. Okay, so that's good. Okay, so we're gonna impl, and I think TryFrom makes a lot of sense because we know we've got at least one way this can fail. Again, the server promises to only send properly formed packets, but in the real world, you wouldn't want to assume that. So I think having a TryFrom makes a lot of sense. And that's going to be from a reference to U8, right? And it's unhappy because we don't have the thing implemented, right? I assume that's not, yeah. So we have to implement TryFrom. Pub fun TryFrom bytes reference U8 slice provides a result. No, I think it's an option, right? TryFrom. Oh no, it's an error and okay. So it's a result. Self or packet parse error. Boom, bop, bip, to do, bang, bum. Oh, for header. Nope, still not happy. What do we have? Not all trait. Oh, we've got to say what kind of error we have. So type error equals packet parse error. Okay, that part's happier. Pub is unnecessary because it's implied by the trait that we're implementing. Okay, cool. So we're taking a slice of bytes and we're going to return a header packet. That's the battle plan, and a header has a file ID. So we could, let's see, so we should be able to assert that the header should have at least 1, 2, 3 bytes. The smallest possible header would have at least 3 bytes. So we ought to be able to say I don't know if we want all of these things. Maybe having like a billion little variants is going to make the code really kind of icky. Maybe it would be better just to say have an incomplete packet error type. And then we don't have to check all of the different options, because that just sounds like it's going to get really kind of gross. So I think let's actually simplify this a little bit. Rename incomplete packet. And then here we can say, where are we? Oh, right here. If bytes dot len less than 3, we can return packet parse error incomplete, double colon, incomplete packet. Boom. Now we'll assume that we've got at least 3 bytes. We could also, if we wanted to be paranoid, we could assert that packet is header of bytes. Boy, I didn't like that. Oh, assert equal. Oh, no, hang on. Oh, because it returns a result type. Can I do that? I can. Well, that's interesting. So if this returned an error, the question mark would just pass the error on and immediately end execution here. And then if this turned out to not be a header byte, the assertion would fail. But we probably don't really want to panic here. We would actually want to return... Well, actually, I think we do want to panic. Because if this isn't a header, we as programmers shouldn't have called it. I think this is a we goofed, not a we got data we didn't expect. Can't blame somebody else if this isn't a header packet, because we should only call this when we've confirmed already that the bytes are a header packet. So I think that is reasonable. And then we want to the file ID is just bytes 1, so let file ID equals bytes 1, and that should be safe. And then this is where life gets interesting, is am I right that I can string something as bytes goes the other way around? I don't want to Rust parse bytes to string. So from UT8F buffer. Okay. Okay. I think that looks like that's a thing. And it's also the documentation here. Stir from UT8F. Okay. Well, and that returns a result. It's a stir slice. Oh, so that'll be a stir slice. And I'll have to make it into, hey-o, welcome, nice to see you. I'll have to turn that into a string, but we can get there in a second. So it's Stir, what was it? From UTF-8 bytes to ... Okay. Didn't find that. Probably because I need to... Oh. It stood stir. So I'd have to use... I need to use here. What? Wow, that's the first use statement in this. That's interesting. Now it's grumpy. Found slice. I thought that... Oh, I just need the borrow. Okay, that's all. Wada. Yeah, when I was making a decision about what to focus on in my year of programming here, Go and Rust were probably the two primary language candidates. And I decided that Rust was the more... How do I say this? Rust was more different and solved problems I didn't know how to solve in other languages. Whereas Go and Go routines are things that are available in a number of other places. And like I've done a lot of closure programming, and Go routines aren't all that different than channel programming and closure. And so I felt like Rust was the thing I wanted to play with. And I've actually been really happy with that. There are days when I think, really, is this what I want to do? But then there are other days when I think this is awesome. And so I think that I've been pretty happy with this. And I think as an instructor, university faculty, learning Rust has probably been more useful from a educational standpoint than any other language I've thought about. I think that this sort of helps me think about programming in new ways, and I think may help the students learn about programming in new ways. I don't know enough about the Go ecosystem to say kind of what its state is. The Rust sort of back end ecosystem I think is super rich. One of the other projects I'm working on is a web app using WebAssembly and the UYEW library. That I feel like is still very new and in flux in a lot of ways, which I think it is. I don't think they claim differently. But I think the back end side of things is actually like in pretty excellent shape. I've been more likely to be surprised by how much there is than something being missing that I expected to be there. And one of the real advantages of having more experienced Rust programmers like esitsu present is they've been able to point out places where it's like, oh, there's this neat tool that'll do this, and I'm like, holy moly, I had no idea. So that's actually been super useful. So let's see. I think we pretty much have variety on the resume is good, and variety in the brain is also, I think, even more good. So I think we're actually ready now to return a... Oh, let's see. That returned a result. So if there's a UTF-8 error, we're going to need to map that to a packet parse error and question mark it would be, I think, a reasonable approach. So boom, 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 boom. Yeah. What am I doing? Mapper. And we don't care. Add a from impl. Oh, sure. We could have a from impl that goes from UTF-8 error. Sure. So impl from capital F from UTF-8 error for packet parse error from EUTF-8 error to packet parse error, and we just want to return a packet parse error, and that's going to be file name parse error, maybe. So that would happen because we're failing to parse this as a string. So we're really failing to parse the file name as a string. So I don't know. I guess I can go with that, unless somebody's got a better option. So what that will do for folks that are not familiar with Rust, boom, is now I can question mark here, right? Yes, sweet. And actually I don't need to break this into another line because it's going to get nice and short. So question mark would normally take the error that this, if this returns an error type, question mark will just return that error type. Problem is we have the error type being a packet parse error, and from UTF-8 the error type is a UTF-8 error, so we've got to convert the one to the other, and we can implement the from trait saying this is how you want to convert a UTF-8 error to a packet parse error. And if we provide that implementation, then anytime it sees a UTF-8 error and it knows that we want a packet parse error, then it will use this to make that happen. And we don't need a name on that error because we never use it. So this will kind of automatically take the UTF-8 error that this could return, and if it does return it, the question mark will cause it to return that error, but compiler can look at the type here and say, but I've got a UTF-8 error, but I'm supposed to return a packet parse error. Oh no! And it will then use the from trait that we've got here to do that conversion for us. And I don't have to, I could have used map _ERR to convert the one to the other, but this way we don't have to add that complication here. Now, there's a question of like, will this ever come up somewhere else? And if it doesn't, then maybe it would have been simpler to have a map here. But certainly if it comes up 2 or more times, it makes more sense to have had it here. And we'll have to like think about the readability later, but I think this actually gets us to a pretty good place. And so then we can return a header file ID and file name. Oops. And it's grumpy because this has the wrong type. Oh no, it's grumpy because we don't have an OK around this. May also be grumpy about the typing, but yeah. So now it's grumpy because it expected a string, but it got a stir slice. And we need to actually turn that into a string because we need it to make sure we can own that data and not have a reference to it, because the buffer that this set of bytes is coming from could be overwritten later. So I think toString seems like a great idea here. And now that's a string, and we've got a header. Whoa! Go team. So we check to see if the number of bytes is less than 3, and if it is, we return an incomplete packet error. And we assert that it is a header packet, and that the question mark will return a packet parse error if the is header returns a packet parse error. If this fails, this will panic, which is, I think, still the right answer. At that point, we should be able to say that the file ID is the first byte, and the file name is what we get by parsing bytes to and forward. Oh, no, not to and forward. We got to be careful here. Yeah, I totally understand. We got to be a little careful here, because this is going to actually take, well, no, well, depends. Somewhere we have to, let's see, that's here, no, that's here, yeah. When we get the packet from the socket, one of the things that will be given is how many bytes there were actually written into the buffer. And we need to use that to constrain, for example, the number of bytes in the file name. Because if we've got a 1028 byte buffer, but we're only have a 7 byte file name, we're only using 9 bytes. And that means somewhere we've got to take that number that we get before we start passing stuff around. And the question is going to be, where is that going to happen? And I think that I'm actually going to assume that it happens where we receive the packet, because at that point we will get the packet size, the number of bytes that were read, as part of the read call, the result of the read call. And at that point we ought to be able to take the slice that's only the part that matters, and then pass that around. So I think it's okay to assume here, so convert the given, actually maybe I want to put that down here. Whoops, undo and scoot over. Byte slice to a header packet. This assumes the given slice that all the bytes in the given slice are used, i.e. there are no empty or unused bytes at the end. and that, oh, so this assumes a lot of things. So let's actually all the bytes are used. There are at least 3 bytes. The minimal size for a header packet. This is actually a header packet, i.e. the first byte is even. Bytes 2 ... can be parsed as a string. And that last assumption isn't guaranteed because Rust supports things like, well, full Unicode, and you can have weird sequences of bytes that don't actually parse the legal Unicode. So it is possible that this from UTF-8 could fail because this array of bytes isn't a legitimate sequence of Unicode characters to make a string. So that is actually an assumption, and if it fails, we will get an error. In particular, we will get a packet parse error. Actually, we'll get a file name parse error. So, okay. So I think that looks reasonable. What time is it? It's 3:32. Let's write some tests for this puppy and confirm that we can actually do some conversion. And then that, I don't know if that'll get us to the end or not, but we will at least have finished the header packet part, and then we can start the data packet part if we haven't run out of time. So, so then my mod tests, I really feel like I want to make this like is header tests, so that and then I really don't need to import everything. I can make this a little more constrained. Import that and import that. Yeah. And so that puts those together in a little bundle. So it'll be a little easier to figure out what's going on later. And so we want to do something similar. Mod oh, I need CFG test. Mod parse header tests. Yep. And so I'm going to want a function that let me think, look at my thing. So what do we have here? We've got, well, the first thing to check is that if we have too short a array of bytes, we should get an incomplete packet. So well, we could say error on empty array again. Let bytes vec u8 equals vec bang let result equals header parse. What do I call it? Oh, it's in a TryFrom, so it's actually TryFrom. Yeah. So I want result to be try from, and I think if I say result is a I feel like I need a type on result or it won't know, because if I do that it doesn't know what to try to convert the bytes to. So is it header? No. Oh, I need to bring header in. Import super header. And oh, it's got to be a reference to the bytes. Constantly make that mistake. I'm still not happy. Oh, interesting. So it's not coping with this being a vector. Can this be a, can I make this a U8 array? No. Because that makes a vector. And I don't want to. So I think and that didn't turn into that's weird, because here these turned into, thanks for following, appreciate that. These turned into a, so is header takes, is header, where's is header? Takes a slice and TryFrom takes a slice. So why is it? Because this is constraining us to only work. Maybe this should be reference vacuate. But then this is going to break all this, and I really want those to be slices, so I don't think that's the right answer. So do I need to convert my vector to a slice? Really? Well, aren't you clever? Really? So star on the vector. So what? So bytes is a vec U8. Star of that gives us a U8. Really? And then the ampersand gives us a reference to that. So I don't know that I understand why a star on a vec gives us a slice. That's not obvious to me. well, I guess a vector is a pointer to, so it's a sort of a wrapper around some bytes in memory somewhere. And so it's a pointer to those. So starring takes us through the pointer and gives us the thing being pointed to. And so vec implements deref to the array of underlying things. Okay, well, I will take that as a deal. I don't know that would. This is one of these moments where it makes sense. I can see why somebody did that, but it's not obvious to me that was a sensible thing to do. Like, I wouldn't have assumed that was the way the world was put together. And there are definitely moments still frequently in Rust where I get to something like this and I'm just like, there is an alphabet soup of funny symbols and they collectively do a thing. Do I understand the thing that they do? I wish I understood it better sometimes, or understood it more quickly. Like, I think if you had not recommended that, I don't know if I would have gotten there very quickly. So that gives us a result type, and that should be a type, the packet parse error, : incomplete packet. Blue? Oops, why are we grumpy? Header needs to be partial eq. Constantly have to do that. Where's header? Header is going to need a partial eq. I wonder if it's also going to need debug. I'm kind of guessing it does. Okay. So because isHeader is explicit here, it coerced the vec into a U8. But here there could have been a TryFrom with a vector reference, and so it doesn't know for sure that I want to use this one. So I have to be more explicit to say, no, I really did want to use this TryFrom and not some other TryFrom that I haven't defined yet or is somewhere else that I didn't import or whatever. Yeah, okay, I think. So this is going to need derive partial eq. I bet I'm going to need debug before I'm done. But I'll let the system tell me. This is probably about to say I need debug. Yep. And I did them in order: debug, partial eq up there, so I'll follow that order. And I will presumably need that on the data struct as well. So I'm just going to put that now so that that's taken care of. And this needs to be marked as a test. And now we can run that. And it passes. Whoa! And we could also have fun error on short array. Let bytes vec u8 equals vec bang. Let's give it 2 bytes. When we assert that it should be at least 3. And then incomplete packet again should be the answer. Oh, I need the test. Test. Ba-da-ba-ba-ba. Let's run that guy. Yay. If we run them both, we should get 2 passing. Yay. Now, come back up to our code. So I think that takes care of this part. We want to make sure that it is a header. And can we easily assert that something panics? I don't know. Fun non-header panics assert panic? Nope. Rust assert panic. Assert panic. Oh, that's a crate. Is there like some other way to... Oh, should panic. There we go. So that's what I'm looking for. So this should panic. And so I should be able to say let bytes vec u8 equals vec bang 1s 5 8 9 6 3 2 0. Let result equals header try from bytes. And I guess we really don't even need the let. And we need to add test. Run that test. Whoa. Oh, it passed. It's just we got the dump as part of running the test. That's a little weird. Because it gives us sort of more cluttered output. If we run all the tests, yeah, we do get all that stuff. Well, that's okay. And now, did I even need the let, or was it sufficient to just do that? Yeah, okay. Oh, but it's marked as must used, so in fact I'm probably better off with the let. Okay, zippity doo dah. So there we've handled all the error cases, and what? So we've handled this, we've handled this. So now we actually have the, oh no, we do have one other instance where it might fail. So we'd have to come up with an illegal sequence of bytes. Oh, thank you, esitsu. Sorry, I didn't notice, but we got to the same place. So I would need something like a 2-byte sequence, but only provide one of the bytes. Oh, actually, thank you. Let me grab that. Copy. Oops, that would be here. Boop. Okay. So I should look at that. I will save that for another day. So is there a simple way I can make an illegal example of illegal Unicode byte sequence? This is the error values return. Oh, the Unicode standard officially forbids values in that range. So we could perhaps just stick something like that in a byte. Oh. So you're saying I could say what particular kind of... Oh, yeah. So that would actually be very helpful. Good call. Thank you, esitsu. So this, we can say something about first byte not even, so not a header packet. And now if we run that test, presumably that comes out somewhere. First byte not even, so not a header packet. Oh. But, that's got to be here. No. That failed. So, panic. Panic does things. Interesting. Do I want to get into this? So that could be in the assertion, right? So where I assert here, I could have a message, which I don't have at the moment. And so I could actually just have that string that I put down here. And actually maybe that's not, if that's going to be the assertion mechanism. Maybe we say expected a header packet. Maybe that, I think actually thinking about it, that goes here, but first byte was not even. So that tells us what we were expecting and what the problem was. And then we find the assertion right here. Okay. And now in theory, we get one passed. Yeah. Cool. And we have the message here, panicked at a header packet, expected a header packet, the first byte was not even. Very cool. Very cool. Thank you. Big help. And that way we know that we got the right panic. It's interesting that it's going to check that based on the string, but maybe that's really all we can do. I'm sort of used to try-catch exception handling in Java, where you can check for a particular exception being thrown, but panics aren't like that. They just quit immediately. And so you don't really have a type. Really all you've got is that it quit and here's the message. And so the message is probably the only thing you really have to work with. Okay. I buy that. Let's see, what time is it? Ooh, it's nearly 3 and 4. And I don't know that I want to get into this right now. And so I think maybe I'm going to stop there. And we can talk a little bit about the calendar moving forward, because it's a little weird next week. It actually might be a little weird through October, and I've got to work out what some of the October stuff looks like. But definitely the next week is a little weird. So, for those of you who are new, and we got a lot of people here today, normally I've been, or at least for the last month or so, I've been streaming on Saturday morning from 10 to noon Central Time, Saturday afternoon from 2 to 4, that's this stream, Tuesday morning from 10 to noon, and Wednesday night from 7 to 9. This week, a lot of that gets blown up. In fact, only one of those 4 sessions is going to happen. So, the Tuesday morning session is not going to happen because I'm having a dental appointment, get my teeth cleaned and stuff like that. So that's exciting. But coding would be more fun, but got to look after one's health. Wednesday night will happen, and I'll update the schedule on Twitch, so you should be able to see. The only one I'm having all week esitsu is the one where you get no sleep, which is just rude, and I apologize profusely. That is just, not cool. That's how the week worked out. But the only one is the one where you don't sleep, and I am super sad about that. I could possibly, I'd have to check with my wife. Maybe I could do a Wednesday morning instead of a Tuesday morning. There we go. That would be good. To try to make up for some of the missing slots for a Thursday morning or something. But at the moment, it looks like Tuesday's out. Wednesday should happen. But then both of next Saturday's streams are canceled. So we're having the Prairie Light Film Festival here we're in a very small town of about 5,000 people in rural Minnesota. We're really in the middle of nowhere. And there's a bunch of people that got some grant money and are putting together this very cool film festival for a week where a lot of really interesting films will be coming. And that is going to block the Saturday afternoon slot because there's actually a University of Minnesota Morris alum who's coming back to talk about having gone to Hollywood to become a filmmaker and show a couple of the shorts that they've done. And in the morning, I've got a local climate network meeting that overlaps. So all of Saturday's gone, Tuesday's gone, Wednesday night, the one where if you're in Europe, it's at a stupidly late time and you should be doing something else with your time probably, is the only slot that's currently going to happen. I will mark all this on the Twitch calendar. I will also update all this on the Discord, and I just posted the link to the Discord channel. So I'll try to have updated information on slots, especially if I decide to add another slot like in the morning sometime during the week, since so much else has been blocked away because of the film festival. So and then to complicate things further, and I haven't really looked at this very carefully, so I don't know for sure what impact this has, but somewhere in like the week of the somewhere the week of the 10th of October, so that's only 2 weeks from now, we'll be going to Wisconsin to visit family So our child is now a grad student in Madison, and we haven't seen them since their semester started, so we're going to go out and visit them. My mom and my sister live up in Oshkosh in north-ish Wisconsin. So we're going to go up there and visit them, and there'll be some stuff happening at the family farm in southern Wisconsin, and we're going to go to that. So we're going to be wandering around Wisconsin for like a week and a half or 2 weeks. And I might try to take some gear and see if I can do some streaming, especially when we're up at my sister and her husband's, because they've got good Wi-Fi and everything. And they'll both be at work during the day, so I could probably do some sort of morning sessions. But I have not sat down and tried to work out what that would look like. When I have something figured out, I will add it to the calendar on Twitch and post it on Discord, and I will also try to update things on Twitter as they're happening. So all very confusing, and I apologize for kind of a chaotic October coming up, late September and October. But that's what happens when you have a life and you want to do other things and not just program 24/7. Although I liked programming, and I thought today was really productive. I was very happy with the packet work. I think it should be pretty easy to finish up the packet parsing in another session. Well, yeah, probably, because we spent a lot of the beginning of the session just talking about the problem was. We have a lot of infrastructure in place now. So I have to see how the parsing plays out for the packet numbers in particular. I think that's the one thing that might be a little odd. But I think parsing data packets should be pretty straightforward. And then it'll be a matter of hooking up the socket stuff with the Tokyo library and grabbing the buffers of raw bytes and then cutting them off at the right place and passing them this parsing code. And we should magically get packets. And actually, once we have collections of packets, then the rest of it's not that bad. We might finish this in 2 or 3, probably not 2, maybe 3 or 4. I should always double and then round up because it always takes longer than I think. But we should be able to finish this in not too many more sessions, I don't think. Because I've written this code in Java, so I have an understanding of where I'm headed. And so it's really just the language issues and figuring out where the error handling, how that's going to move around the system. But I do really like having these things return result. I think that actually is really quite nice to be explicit about the fact that things can fail. Yeah, I think that's actually really good. And I think that's going to clean some things up for us. And I think the borrowing is going to save us in an important way from a problem that students frequently run into. Okay, I'm going to stop. You're all awesome human beings. Thank you so much for spending time with me today, and all the feedback and the suggestions, helping me figure out what I'm doing as I do it. I will not see you Tuesday morning. I will hopefully see some of you Wednesday night. Wednesday night we'll be doing evolutionary computation in Rust. So we'll be working on the Rust GA project, which is getting, as long as I don't overcomplicate things, because I keep wanting to overcomplicate things, I think we're getting to a pretty reasonable place there, and we basically have one more piece to sort out. And then I want to do some timing comparisons between Rust and Clojure and see how they play out. So I think we're in pretty good shape there. And then we'll hopefully return to this, not next Saturday because I'll be at the film festival, but hopefully the Saturday after that we'll come back to this. So that would be the 8th or 6th or something of October. No, the 9th. Is that really true? Yes. No. The 8th. The 8th of October. Hopefully we'll be back here doing this. Maybe. Yeah, we'll see. Actually, there's an issue on the 8th I've forgotten about as well. So the campus radio station is having its 50th anniversary. That's homecoming weekend for us. And they're having their 50th anniversary. And I have been the faculty advisor for the radio station for slightly more than half of those 50 years. 27, something like that. And so I would really like to be there for some of the events. And there's not a schedule yet. So I don't know what's going to be happening when. But, so there might be conflicts with the 8th as well, which then if the 15th doesn't work, which it won't, it could be like almost a month before we come back to this. Oh, I'm so sad. This makes me very, very unhappy. Yeah, I might try to have to fit some extra slots in. I don't know. We'll see. I will say things on Discord and on Twitter, and I will update the Twitch calendar. And I will stop babbling. You're wonderful people. I'm going to go away, and I will talk to you later. Thank you very much for being here. Goodbye.